Science and God, Part 4. Now we're moving into physics and cosmology. We're going to talk about the Big Bang. I'm sure you have heard of it, but can you explain it? I hope you're not worried about it, because it's really faith building. Big Bang says that at a point in time and space there was nothing. Nothing. It's hard to grasp. But in the next instance, the entire universe came into existence in a huge flash of light. So it basically says the universe was created from nothing. That sounds a bit like the first chapter in the Bible. If you read Genesis 1, it says that in the beginning, it has no date, there was emptiness, and suddenly there was light, and everything came into existence. If we just go back 100 years, most physicists meant that the universe was not created, that they believed in a steady-state universe that had always existed. Even Einstein believed in that universe, and he made the general theory of relativity. There he added a factor, lambda. You can see it to the right of the middle of the equation, and that helped the equation to be correct even in some circumstances that he could not explain why. So it's just a added factor for things he couldn't explain. Of course, Einstein, he changed when he got to know more of the facts, how the universe works. But in 1929, Edwin Hubble, you know, the Hubble telescope, I guess, that takes beautiful pictures from the universe. Mr. Hubble, he discovered that the universe is immensely huge, and it is actually expanding, so it's not steady state. Then a few years later, there was a Catholic priest who proposed a theory of the Big Bang. He didn't call it the Big Bang theory, but his opponents, actually a man from the newspaper, called it a Big Bang to mock him. But that caught on, so we still call it the Big Bang theory. And later there were other scientific discoveries. Of course, they found out that there was antimatter and quarks should be there, and then they found them. And finally, in 1963, they found the background radiation from the Big Bang. They said that at a big explosion there should be a radiation after that with a specific temperature, and they did find it. By accident, though. In the 1970s and 80s, they discovered dark matter. It's a hypothetical matter, so you can't see it. It's not visible. But it does not interact with the electromagnetic force, but it interferes with the gravitational effects on visible matter. So it should be there, though you can't see it. That's a fun thing for a scientist to propose. And in 1998, cosmic acceleration was discovered, that the cosmos is accelerating. And they couldn't explain that, so they thought out something they call dark energy. Dark energy is also a hypothetical form of energy that permeates all space and tends to increase the rate of expansion of our universe. So now they say only 4% of our universe can be seen, and 22% should be dark matter, and 74% is dark energy. So that's a claim of faith, I guess. Back to the Big Bang is the best cosmological model that we have still today. It fits with evidence, with observations, and there have been many studies, and is still the best model that we have. Winding the film backwards, it looks like it should have taken place about 13.7 billion years ago. At that time, T equals 0, we had the Big Bang. The temperature was so extreme you can't even imagine, not just thousands or millions degrees, but way up there. So none of the physical laws did actually work at that time. So they divided the first second into different epochs, and we'll skip those. They are very technical and theoretical. Nobody could prove that at this time. But at 1 minute we have the photon epoch, where the light is starting to shine in the first gel, big blob of a universe. After 3 minutes we have what they call the Big Bang nucleosynthesis. So it's just a few minutes after the Big Bang, and we have formation of the first atoms: deuterium and tritium, helium, lithium, and finally beryllium. But after 20 minutes, supposedly it was too cold for other atoms to be the heavier to be created. So the temperature was 10 to 9th Kelvin, that is about 1 billion degrees. Then there was a period that's called the Dark Ages. Let's skip to the next slide. Now we're not into seconds or minutes, but we're into millions of years. After 100 million years, we have the first galaxies, the first stars, 600 million years, first galaxies. And we'll move on. After 9 billion years, the Sun and the Earth were created. And today, it's about 13.7 billion years after the Big Bang. And now we have life on Earth. That's a good thing. So in a few 3-4 billion years, the sun, our sun, will become a red giant and later a white dwarf, so we won't have any life in our solar system anymore. And later things will not look too good. The stars and solar system won't exist, neither will the galaxies finally. And then we'll either have a big crunch, so everything implodes, or we'll have a big freeze where everything just gets cooler and cooler, and there's no order and no stars, no planets. But it's a long time from now, so don't worry about that. Let's just look at big numbers. 10 to the 9th. It doesn't look that big for a mathematician. But if you were counting 1, 2, 3, a number per second, if you do that day and night without rest, it will take about 32 years to reach 1 billion. So it is a big number. Not many people have $1 billion, for instance. 10 to the 18th, it's not twice as much as 10 to the 9th, but it's a billion times a billion. And that is actually, if you're talking about 10 to the 18th seconds, it's twice as long as the universe has been in existence. So that's a big number. 10 to the 80th is one of the largest numbers we can find, because it's the number of atoms in the universe. So what are the odds in winning in Lotto, or whatever it's called where you live? In Denmark, it's 1 in 10 million, 10 to the 7th. That's not a very large number, but it's not very likely that I will win, I guess. What about 1 in 10th to 116? That's the maximum imbalance between the gravitational force and the amount of energy in the universe for it to exist today. That's a huge, huge number. We can't even imagine that. Would we play the lottery with these odds? Is it likely that the universe even would exist today if it wasn't for a designer that had balanced the forces extremely well? If the gravitational force would be a bit stronger, the universe wouldn't exist. It would have imploded again. And if it would be bigger, it would just have expanded, and we wouldn't have planets or even atoms, probably. So there is not only the gravitational force that is extremely well tuned, but also the size of the electrical force and the nuclear forces. They also have to be balanced extremely well. You can't tune an instrument with this precision, but the universe is extremely well tuned. So that's what we call a fat chance universe. To sum up this little presentation about the Big Bang, the universe was created from nothing, like the Bible says in its first chapter. The forces are extremely well balanced. And I think there's a God behind it, and imagine how smart he must be. First he had to think of all the forces. Then he had to make them just right in size and in function. Then he had to think up a universe with the elements that we need and with the right properties. You know, we have more than 100 elements and we need them to sustain life. Then he had to make it out of nothing. And that's not a religious claim, it's a claim of scientists, even atheist scientists. Big Bang says that everything came out of nothing. So that's pretty smart and pretty powerful. Well, God is cool. Thank you for listening.